Again, it's a red stick.
What is going on, guys? Welcome back. In this video I'm going to show you how to do asymmetric encryption in the command line using OpenSSL. Now, asymmetric encryption means that we don't use the same key for encryption as for decryption. So we don't have a password which we use to encrypt something and then we use the same password to decrypt it. We have a private key and a public key, and we use one key to encrypt and one key to decrypt. So you can encrypt with a private key, you can decrypt with a public key, or you can encrypt with a public key and decrypt with a private key, and this allows for a secure communication. This is what we're going to do today. I'm going to go right into the command line here. I'm going to use the Windows subsystem for Linux here, but keep in mind you can do this on Windows natively, you can do this on Linux natively, and you can do this on Mac. All you need is OpenSSL. You can check if you have OpenSSL installed by typing OpenSSL like that. If it opens the shell, you have OpenSSL installed. Otherwise, you need to install it. You need to type sudo apt install OpenSSL. And this is for Debian-based distributions. Otherwise, you use Pacman or DNF. For Windows, just use Google, download OpenSSL, whatever. It usually comes with Git, so you probably don't have to install it if you have Git installed. Now, let me just resize my camera so that you can see more of the commands because they're going to get quite long. The first thing we want to do is we want to generate a private key. This is going to be our private key. We don't want to share this key with anyone. We want to have a password protected private key so that we basically have a symmetric encryption for the private key. So we encrypt the private key itself. You don't have to do this, obviously, but you want to have a private key, and this private key is then going to be your authentication. So when you encrypt something with a private key, everyone that has your public key, and you're going to distribute your public key, you can put it online, you can send it to people. The public key doesn't have to be secret. Everyone who has your public key will be able to decrypt everything that you encrypt with your private key. And everyone who encrypts something for you using the public key and sends it to you, you're going to be able to decrypt that using your private key, and no one else is going to be able to decrypt that. So we're going to generate this private key first. We're going to say OpenSSL gen RSA, and then we're going to specify a cipher. Now you can go with DES3 if you want. I'm going to go with Advanced Encryption Standard 256 CBC, which is a block cipher. And what we're going to basically specify is that we want the output to be my private.key, for example. You can name this whatever you want. So you can see it generated it, and it's now asking for a passphrase. It's asking for a passphrase because I specified a cipher. So this means that I want to encrypt my private key, the private key itself. So I don't want to just have the private key. I want to have an encrypted private key that I need a passphrase for in order to be able to use it. So let's say the password is neural9. There you go. And now I have this private key here. This is the private key. I can also create a private key without a cipher. So I can go ahead and run the same command here without specifying a cipher. And I'm going to call this my private2 key. And you can see it didn't ask for a password. And I can use this key now for signing or for decrypting without specifying a password. Whenever I want to use the first key, I need to specify a password. So it's a bit more secure. I have this encrypted symmetrically, so I always have to enter the password if I want to do something with it. Let's remove the second one. We won't need it. By the way, let's create a separate directory. Let's call it tutorial. And let's move the private key to tutorial. Let's go to tutorial. Let's clear the screen. So now we have the private key here, and from this private key, we can now derive a public key. So we can use this private key to generate a public key. And for that, what we do is we say OpenSSL RSA in, and we pass the private key as an input. And then we say pub out for public key out, and we're going to create this public.key. Now, in order to be able to do that, we need to enter the passphrase for the private key because it's protected. And we're going to enter neural9. There you go. Writing RSA key. And now we have this public key. Now, if I enter the wrong password, we can try that as well. If I type just something, you can see unable to load private key. We cannot use it because we don't have the proper password. There you go. All right. So now we have the public key that we can use for communication. The idea is that we now put this public key, for example, on our personal website. Everyone can see this public key and say, okay, if I encrypt something with that, the only one who can decrypt the message is the one who has the private key. And of course, this is something that we hope for, but I should be the only one who has the private key. No one else should have the private key, and the private key is the only thing that can decrypt something encrypted with a public key. And also, if I want to encrypt something using the private key, everyone of course can decrypt it with a public key, but only if they can decrypt it with a public key, they can know it's authentic, it's from me, because if they try to decrypt something else that was encrypted with another key, they're not going to be able to do that, and they're going to see, okay, this is not from me. So I can encrypt something using the private key to show that it's from me, it's authentic, it's signed with my private key, so to say. All right, so what I can do now in order to encrypt something is I can use OpenSSL RSA util, like that, RSA UTL, and we're going to type encrypt, encrypt, and we're going to use this in key, the public key, my public key, and we're going to say pub in, then in, and we're going to pass, oh, we don't have a message yet, so we're going to define a message for it. We're going to create a message first, message.txt. Hey, I am a secret message. You can now read me. Like that. Now, let's go to the command again, OpenSSL RSA util, then encrypt, then in key is my public key, then pub in is going to be message.txt, and out is going to be the encrypted message. So message.enc. In this scenario, you guys, for example, have the public key. Again, the public key is not secret. Everyone can know it. And if you guys encrypt something using the public key, you would do it like that. And then if I now try to read whatever is in the encrypted message, I cannot read it. It's encrypted. And no one can actually read this unless they have the private key and are able to decrypt that. And how do we do that? We basically run a similar command, OpenSSL RSA util decrypt, like that, and the key for the decryption is going to be the private key, and the text that we're going to decrypt is going to be message.enc, and I'm going to get the output to clear.txt. And of course I will need the password for this, otherwise it won't work. And if I enter the correct password, I will see that this is the decrypted message. So this is how it basically works. Now let us talk about a practical scenario where two people, Alice and Bob, want to communicate securely using asymmetric encryption. How can they do that? And for that, we're going to create a directory here, scenario, and we're going to have inside of this directory one for Alice and one for Bob. The idea is that here the directories represent like two different locations, computers, networks, whatever. In reality, Alice will have one computer in one network, maybe in a different country, and Bob will have his computer in a different country, and so on. And the first thing that they need to do is they need to both generate a private key. For that, I'm going to now split this here, and we're going to go to tutorial scenario Bob down here, and we're going to go to Alice up here. Now, what they both need to do is they need to generate a private key. So we're going to say OpenSSL gen RSA, and we're going to use Advanced Encryption Standard 256 CBC for a block cipher, and we're going to say out is going to be Alice private.key and 4096. I hope my camera is not blocking that. Is it? No, it's not. So we're going to generate this for Alice now. And I can pass a key, for example, 12345 is going to be the password for Alice private key, and for Bob we're going to do the same thing, OpenSSL gen RSA. They don't have to use the same cipher, by the way. They just need to know or actually, I don't even think that they need to know the cipher, do they? No, they don't even need to know the cipher. So here we can go with des3, for example. Doesn't really matter, because Bob's key is not going to be related to Alice's key. Just Bob's public key is going to be related to Bob's private key. So we can use a different standard here. So we're going to use des3, and we're going to say out is going to be Bob private.key 4096, like that. And the password here is going to be password. There you go. Now they both have private keys. We need to derive the public key. So what we're going to say is OpenSSL again, RSA in Alice private key, pub out Alice public key, like that. And the password here was 12345. There you go. We now have the key. And here we're going to do the same thing. OpenSSL RSA in Bob private key pub out Bob public dot key. And the password here was password. Right. All right. So now now we have the public key and a private key for both people here, and what they're going to do now is they're going to exchange public keys. How they do it doesn't really matter, because the public key is not dangerous. You can put the public key on your website. It doesn't matter. They can send it via WhatsApp. They can send it via mail. Doesn't matter. They just need to know it's authentic. This is important, of course. They need to know it's authentic. So it shouldn't be the public key of someone else. So they have to have a connection that they know is, not in any way malicious. They need to know that the communication works. So it doesn't matter if someone else reads the key, but it needs to be the right key. So for example, in this case, we're just going to copy the key, the Alice public key. We're going to copy it to Bob's directory, and we're going to do the same thing with the public key of Bob. And we're going to copy this to Alice directory. Now, again, this can be done via mail. This can be done via SCP, whatever. And now what Alice can do is Alice can say, okay, I want to send a message to Bob that only Bob can read and no one else can read. So what Alice can do is Alice can say nv loveletter.txt, for example. Bob, I love you. Let's meet at the park at 10:30. No, let's meet on GitHub, because we don't go out, we're programmers. And now we can say, again, we can just encrypt this love letter and send it to Bob. Now we need to encrypt it using the public key of Bob, and then we know that. Now we can also sign this using the private key so that Bob knows that this is from Alice. So what we can do now is we can say OpenSSL RS a util encrypt, and we're going to encrypt this using Bob's public key, and the message that we want to encrypt is the love letter, and it's going to result in secret.enc. So we didn't need any password to encrypt because we used the public key. The public key is not password protected. Now, this is the password. We can again look into it and see that it's basically unreadable. Now, of course, we're going to remove the love letters so we don't have it anymore. And what I now can do is I can send this to Bob. So I can say secret copy it to Bob's directory. And what Bob can do now is Bob can go ahead and say, okay, OpenSSL RS a util decrypt. And this time he uses his private key, of course. And what we want to decrypt is that. And we want to have this as message.txt. We enter password here as a passphrase. And if I now say message.txt, we can see, Bob, I love you. Let's meet on GitHub. Now, we only know that someone sent this message. I mean, that's what we know for sure. Someone sent this message and it was encrypted for us, or for Bob in this case. we don't know for sure that Alice sent this message. So what we can also do here is we can take the encrypted message and we can sign it with the private key of Alice so that Bob can then first decrypt it with the public key of Alice to know, okay, this is definitely from Alice. And then he can go ahead and decrypt it with a private key. So basically, we can go up here and all we need to change is, first of all, the key. So we need to encrypt this with a private key. Alice private key. And actually, do we need pub in? I'm not sure if this is going to work even. Well, let's see. Maybe it's going to work. Secret enc, and the output is going to be signed.enc. I hope this will work. I'm not sure. Unable to load public key. Okay, maybe. All right, it seems like I was talking nonsense. We need to do it in a different way. We cannot just encrypt with the private key. We need to encrypt with the public key. We always need to decrypt with the private key, but we can make a signature. We can create a signature that proves that Alice actually created this file by signing it, basically, by also sending a signature to Bob. And how do we do that? Again, we have the secret encryption file here. And what we do is we say OpenSSL DGST. I think this stands for digest. And then we say SHA-256 or any hashing algorithm dash sign. And then we're going to sign with the private key. So Alice private.key. We're going to sign here. We're going to create a signer file. Let's call it signer. You can call this whatever you want. I'm going to call it signer. And we're going to create this file based on secret.enc. So we're going to sign the secret.enc file using the private key. We're going to say 1, 2, 3, 4, 5 here. And now we're going to encode this with base 64. So OpenSSL base 64. And we're going to get the signer. And what we get out is the signature, or let's call it Alice underscore signature. There you go. So now we have this signature, and what we can do now, we send the message to Bob. Bob has the message. What we also do now, in addition to the message, we also send to Bob the signature. So we say copy Alice signature to Bob. And now Bob has secret.enc, and he also has the public key of Alice, and he has the signature of Alice. And what he can do with that is he can say OpenSSL first, the code base 64, so base 64-D, and what we get here is the Alice signature, and what we want to have out is the signer file again, and yeah, that's basically it. And then what we need to do is we need to call this function again in a reversed way. So we need to say OpenSSL digest SHA-256, and we want to verify. We want to verify that using Alice public key, using the public key of Alice and the signature that we got, so the signer, that this file is authentic, that secret.enc is authentic, and we can see that's totally the case, that's true. Now, this will not work with other keys. This will only work when Alice signs it with a private key and Bob verifies it with a public key. And now Bob can know, okay, the message that I decrypted from the secret encryption is this message. I can read it now. It is Bob, I love you, and I have the verification that this is actually signed by Alice. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.